Welcome to System Programming Crash Course. Yes, we were discussing about a program. It's okay. The method we used was long way no looping. That is what we saw in the previous class. So just take a look. So see if you remember it. So we were using three instructions: load instruction, add instruction, and store instruction. We kept repeating that because we said there was no way of looping. So this is what we did. Okay, so let us go to the next technique. What we are going to follow, let us little more effective. It is going to be little more effective. Let us see how that works. Right. So this is the technique I want to tell you now, and then move on to the third technique. There is also another technique, and then of these two, which is the best way or efficient way, is what we are going to decide. Okay. Yes. So this particular technique is called address modification using index register. Okay, address modification using index register. So what does that means? The coding, if you see, it is slightly similar to what we have already seen, already done in the previous method. Whatever we did, it is very similar to that, but it is only similar, it is exactly not the same. Yes, so we will slowly come to this. So I will leave the other commands. I will go to the, first of all I wanted to take the load command. So first I would like to touch the load command, then we will go back to the previous command and all. Right. So here what happens? So as we all already know, we have the number. First number is going to be stored at location 904. So first number is at location 904. This is nothing but your data 1. So load that first number, put it in register 2. Okay. Take 49 from location 900, add it to register 2, and the sum has to be put back in 904. Yeah, till this there is no difference. It is the same. But here the difference is only going to be with your index register. Okay, the difference is going to be only with your index register. Index register is first information is which was your index register previously, previous case 0 was your index register. Okay, the first change here is register 4 is my index register. Okay, register 4 is my index register. Should that change anything? No. There can be contents of register 4 is 0, also the meaning is going to be same only, any register you can use. But why have we actually used 4 is indirectly to say that that register value is going to increment by 4. That is what it is going to do. That register 4 is going to increment by 4 every time. Okay, that is what is the, that's why indirectly we are just saying register 4, so that you should remember that it will, that will be done. Right, how is that, we will see that little later. Right, so instead of index register 0, here the index register is register 4. That's it, no other change in the program. Yes, can you see that? Do you agree? There is no change in the program. Instead of 0 comma 1, only in these two places it is 4 comma 1. So that is why I asked you to make an observation in the previous program that in this middle line there is no change. It is going to remain same for all the 10 numbers. Okay, the change is going to be in the first line and the third line of the coding. So only in these two lines the index register is going to be register 4. Here the index register is going to be register 0 only, right? And the contents of register 0 will be 0. Here alone we are going to use register 4. Why? We will see that. Right. So one more thing I would like to remind you is, how do I calculate my absolute address? Absolute address is equal to, tell me, relative address plus index register plus base register. Okay. This is where the actual what do you say, the method actually lies in this particular formula. Okay, this method is address modification using index register. So this particular method, the trick lies in this particular formula. So we are saying anyways, to calculate my absolute address, okay, when I'm going to load the program into the main memory, I will be adding the relative address, I will also be adding the index register number, and also be adding the base register value. Yes, so that I'm going to use that to my favor. Right, see what am I doing here is, at location 904 I have the first number, at location 900 I have the second number. Okay, but I'm going to also introduce another number here, that is nothing but at location 896 I'm just going 4 bytes before. That's it. These addresses you can assume anything, these are all assumptions only. Okay, at 896 I'm going to store value 4. I'm going to store value 4. Right, that is the first assumption. Okay, now see, yes, here first time the register value will be, register 4 value is 0 only, it has to be 0 first. Let us assume that register 4's content is 0 only now. Right, now what happens, what will be my absolute address? So 904 is my relative address. So how will I calculate my absolute address? 904 plus 0 plus 48, which is nothing but 952. No change in that, right? So that is what it is. There is no change here, first line. But if I increment this index register by 4 every time, first time it is 0, okay, next time it will be 4, that time what happens to my absolute address? Absolute address becomes 904 plus 4 plus 48. So what it will become? It will become 956, which is exactly what I wanted. Every time I will say 904 only, but first time I will be accessing the first number, second time I will be accessing the second number, third time I will be accessing the third number, and so on. How? Because I'm directly trying to change the absolute address itself. So though I say 904 only every time, but when I can see the absolute address calculation, I will be actually fetching data from different absolute locations. Yes, I'll be fetching data from different locations. That is exactly what I wanted. Okay, other way of saying this, let us say, assume that this is an array. Okay, so what I'm doing here, so first number I'm going to access it from location 904, second number I'm going to access from location 904 plus 4. Yes, third time I'm going to access the third number from the location 904 plus 8, fourth time I'm going to add 904 plus 12, and so on. Okay, we are using this index register is added. Absolute address is equal to relative address plus index register plus base register. This formula we are going to keep it as a trick, and then keep incrementing register 4 by 4 every time. From first time it will be 0, then it will be 4, then it will be 8, then 12. When you add that to 904, the code remains the same, but what actually happens is, it will absolute address, it is going to change. So what happens actually, the data, different data are going to be picked up every time, and it's going to be added with 49. That's what we want. First time it will pick up data 1, second time it will pick up data 2, third time it will pick up data 3, and so on. That is exactly what we wanted, right? So here is the complete code. Let us see. Complete code, this is the concept. Whatever I told you now is the concept, right? The complete code is here. SR, okay, this is subtraction. Subtract register 4 by register 4. Okay, just use for clearing register 4, that's all. So R4 minus R4 is what? 0. So we are just clearing register 4, that's it, right? So if I don't write that line, is it okay? It is okay. We are just assuming that maybe the contents of register 4 is 0 only, right? We are just clearing it. Clearing register 4 by register 4 minus register 4. Subtract registers 4 comma 4. It is like AR is add register 4 comma 3 we saw yesterday. That is the example we saw. Similarly, subtract register, this is, yes, cleared the register 4. Now register 4 is 0, right? Done. What happens? Register 4 is 0, so 0 plus 904 plus 48, 952. First number I have loaded, and I have done the addition also, no problem. Okay, I'm going here and saying back to branch back to line number 2, which is nothing but your looping. Okay, we don't want to clear the register for every time. That should not happen. First time I clear the register, and then these 3 lines of coding I wanted to repeat it again and again. 10 times I wanted to repeat it. Okay, that's, so I'm going to use branching. Yes, that is the first improvement we did from the previous program. First improvement is we are going to have a looping. So it's going to loop again and again. From line number 2 till line number 4, it is going to repeat 9 times. So one time we have done here, other 9 times it is going to do the repetition. Yes, that is the second point. Yes, third point is, I load a number, I add that number with 49, and I store the sum in the same location. Done, no problem. So how am I going to take various data? Because first time I'm going to take the data, that time register, index register will be 0. Second time index register will be 4. Third time index register will be 8, and so on. How can I do it? I have to add one more line of coding here. That is nothing but whatever is there in location 896. What is there in location 896? Number 4. Okay, add 4 with the register 4. Add 4 with the register 4, and the sum must be stored in register 4 itself. So every time we are going to add 4. First time register is cleared, so it is 0. We execute the code. Then we are going to add 4 to it. It becomes 4. Register 4 is going to be 4. You branch back. Then what you do? 904 plus 4 plus 48. Okay, it will give you the next number, which is at location 956. Right? You come back again, add 4 to the index register was now 4, plus 4 will become 8. Again go back to this and keep doing, looping it 9 times. So using index register, we are looping, we have done our best, and we have tried to make the code efficient. So you don't have to go the long way. You can definitely use looping. So slight modifications you have to do. So what is the trick we are using? The trick we are using is the absolute address formula. Using that, we are trying to directly access the absolute address itself. Instead of accessing relative address and changing the code, I will not change the code directly. I'll go and access the absolute address. So this is how I want to perform this particular operation. So address modification using index register. Yes, hope this is clear. Yes. The next one, so there is another technique we are trying. Okay, the actually the index register technique is the best, right? But still we also have another method. So this method I should have actually explained it before the index register method, but there are some things, no, it is a little more complicated, so I wanted to keep it in the last, right? But out of all the three, index register is going to be the most efficient method. But still, right, this program also I wanted to explain it to you. This is another method. This method is called address modification using instruction as data. Using instruction as data. This is the most interesting program. Okay, so according to me, this is the most interesting program. You cannot do this in any other programming language. You can do such things only here. Only here you are studying all these techniques, right? So it's very interesting. Let us check. Okay, so before going into the program, I wanted to tell you something which we have already done. Okay, we have already discussed that, but I still wanted to have you a glance at it and then come back. Okay, so what is that is, we saw instruction formats. Yes, previous classes we have seen instruction format. I gave you this example also. Yes or no? Instruction formats we saw. I gave you this example. You remember? Yes. So now what I'm going to talk about is your RX instruction. Okay, so what I'm going to talk about now is nothing but your RX instruction. So I think I take a highlight now. Right. Okay, this is the instruction we are going to discuss now, the RX instruction. So whatever we have seen now in what the program I told you, all the instructions are going to be RX instruction only, or are going to be 4 bytes. It is going to be an RX type instruction I told you, right? We had load, store, and add. All these are going to be RX instruction, which means they're all going to follow the same format, same instruction format. Yes. So this instruction format is very important for you to understand that program, right? So what is this instruction format actually? What it says, this instruction actually what we have done is we have assembled that instruction. That is the actual thing we have done. What do you mean by assembling? Assembly level language program has to be converted into zeros and ones, or machine level language. That is exactly what we have done. Yes or no? We have taken one instruction and converted into zeros and ones. If you do that, you have assembled the instruction, is the meaning. Yes or no? Right? So anyways, whenever you load a program into the main memory, it will be the assembled program, which means if I write the coding like this also, ultimately what goes in is this binary representation only is going to be loaded into my main memory for execution. Yes, right, right. So what I'm going to do is, first time I want the what, my relative address first time should be 904 and it should fetch the first data. Second time it should become 908 and fetch the second data. Third time it should become 912 and fetch the third data, and so on. So that is the requirement for that particular program. So what I am trying to do here, this whole integers here, or zeros and ones here, this number here represents 904. So 904's binary conversion is there, right? What if I have to add 4 to it? Say this number is the binary number. I'm going to add 100. Okay, I'm going to add 100. So what this will become, the displacement or the last 12 digits, I'm just going to add 100. What will these digits become? They will become 908. Yes, that is what I want, right? If I directly add 1004 to 904, I will get 908. Okay, then I will again add 4. Okay, this is the concept. So what are we doing actually? We are actually altering the what, instruction itself. We are going to alter the instruction itself. This is the instruction 0101 1010, whatever it is. 1000 means a 2 comma 904 of 0 comma 15 is the meaning, right? However, what am I going to do? I'm going to take the instruction itself and add 4 to the instruction, so that the instruction becomes a 2 comma 908 of 0 comma 15 is what it is going to become once I add 4 to it. You understand? So what are we actually playing with here? We are adding a number to an instruction. We have never done that. We only add data to data. Have we ever added say printf command plus 4 can I do? No. But this is what we are going to do here. What are we doing? We are taking an instruction, adding 4 to the instruction. So is it logically correct? Yeah, if you see this particular syntax or particular format, yes, it is correct logically. How am I doing it? I'm adding 4 to this. So what happens? This displacement alone becomes 908. It becomes 908. So how should I do it? Where will this particular value be available for me? Yes, so that is what we are going to see now, right? So understand the concept. Yeah, let us jump into the program now. Yes, address modification using instruction as data. Address modification using instruction as data. Let us see. At relative location 0, at location 0, I have this code. Yes, at location 0, I have this code. So how will I write this code? What is the format I will use? Opcode will take say 8 bits. Yes or no? Then register 2 will take 4 bits. Then there will be base register, index register, then displacement is going to take 12 bits. Right? So this code actually when I compile it, it will become in it will be in zeros and ones. Exactly like what I showed little before in the other slide. Similarly, at location 4, there is A 2, 900 of 0, 1. At location 8, there is ST, store 2, 904 of 0. This is the same code which we keep using it in all the programs. So same 3 lines only, no change. Okay. So first time it is going to fetch a number from 904, okay, add it with 49 and put it back in 904. So no problem. Next time what it should do, it should fetch a number from 908. It should not fetch from 904. But I don't want it to go change it every time. I don't want to write it 10 times. What if it is 100 times I want to do the same thing? Will I write these 3 lines? Will I do it 100 times? No, that doesn't look good, right? It's not an efficient programming. So what I'm trying to do here is just see this is completely different from these 3 lines. Okay, whatever I'm going to do here is completely different from these 3 lines. Listen carefully. Load, right? 2 comma 0 comma 0 comma 1. Okay, what it means, load the value present in location 0. Yes, so what is present in location 0? So whatever is present in location 0, load that into register 2, right? So what is present there? You have this L, it's an instruction. Okay, but when I say load it into register 2, what will be actually loaded? That zeros and ones. Okay, that assemble instruction, what is going to be loaded in your register 2? That value is going to be loaded to register 2. Yes, so what we are doing, we are directly going to 0, taking this instructions, what assembled value or the instruction we are taking and adding. I'm going to add what, 4 to it. That's what I'm going to do. So first I have to first fetch that in register 2, then only I can add 4 to register 2. You understand? So that is the plan now, right? So for this plan, what is that we are supposed to do is this. Okay, see here again I will tell you, I asked you to make an observation there. That observation is nothing but there is only change in load instruction and store instruction. There is no change in the add instruction. You can repeat the same instruction, nothing will happen. Okay, so whatever we are going to do now, we are going to do only to load and store instruction. We are not going to do it for add instruction. Okay, so what we do here is for the load, changing the load instruction. What we will be doing here is to change the store instruction. That is why what we are doing, from 0 we are going to take and put it in register 2. Okay, similarly store instruction is nothing but 8. So from 8 we are taking the instruction and storing in register 2. You understand? That is what we are doing. So what we do, first 3 lines of coding, adding the first number, done. Again we are taking the code and altering the code itself. I want the code to be altered as L2, 908 of 0, 1. I want to alter this code as ST2, 908 of 0, 1. So how can I do that? I will first take that code. So load the contents of register 0 into register 2. I'm sorry, contents of memory location 0 into register 2. Add 4. So 896 has 4. Add 4 to register 2. Yes, add 4 to register 2. Store it back in location 0. Okay, we will write only 3 lines of code, but we will alter that code itself. When are we altering it? Runtime. So runtime we are altering the code itself. Right. Done? Changed? Yes. Second change I want to do is I will take the instruction from what? Relative address 8. I will take the instruction present in relative address 8, load it in register 2, add 4 to it, and put the sum back into location 8 itself. So what happens after we have completed the executing this particular instruction, the whole code will change. The actual source code is going to change. So how it's going to change? The loaded code, I mean. How it's going to change? It's going to change as L2, 908 of 0, 1, A2, 900 of 0, 1, ST2, 904 of, I'm sorry, 908 of 0, 1. That is how it is going to change. You understand? After executing these three lines second time, again it will execute these two, which means it will again become 912. Okay, 900, this will become 912. Again it will go, it will become 916 and so on. You understand? So this is a very, very interesting program, my favorite one. So here what are we doing? We are taking the instruction itself and we are modifying it when? During runtime, right? That is what we are doing. Hope you understand this. Okay, so this is what we are doing. So write the same three lines, and then these two lines, these three sets, we are going to do it to change the instruction of load and change the instruction of store. You understand? But this is not considered to be very efficient because it changes, it goes and touches the source code itself. Sometimes it may be a problem. So maybe there will be a person who, X who would have written the code, there will be a person Y who will try to execute the code, so they may not understand what has actually gone into it. So touching the code is actually not advised. So not advised. So according to us, the best method is going to be using index register only. So I will use index register. This will be my method from now on. So whatever we are going to study further, other topics, we will be using this index register coding only, right? Yes. So one more thing I actually forgot to tell you when we saw this. So I told you all these are RX instructions. Yes or no? But this one instruction is a RR instruction because register to register. That is why we start at 0. The next one we don't start at 4, we start at 2 because it is only going to occupy 2 bytes. So if we are going to start at 2, then it's going to be 4 bytes only, right? So be thorough in all these three. Any one will is a definite question. Any one definitely it will be asked, right? Same three lines of coding you study, it's enough. Definitely it is going to be asked. It's a definite important question, right? Any one from these three. Thank you.